Hello, students, and welcome to our revision session. Today, we're going to tackle a really interesting chapter, sound. Have you ever wondered how sound is actually made? How does the sound from my voice reach your ears? Well, that's exactly what we're going to revise today, from the very beginning to all its important applications.
So, here's our plan for today. We will start with the production and propagation of sound. Then we'll look at how to describe a sound wave. After that, we will discuss the reflection of sound and the human range of hearing. We'll also cover the many applications of ultrasound. And finally, and very importantly, we will discuss your exam strategy. This will make sure you are fully prepared.
All right, let's begin with our first topic. We're going to understand the fundamentals, basically how sound is created and how it travels from one place to another.
This is the most important, the most basic principle you must remember. Any sound you hear, whether it's a school bell ringing or even my own voice, it all starts with one thing, a vibration. An object must vibrate, move back and forth to produce sound.
So, how does this sound travel? Well, as an object vibrates, it pushes the air particles in front of it. This creates a region of high pressure, which we call a compression. Then, as the object moves back, it creates a region of low pressure, called a rarefaction. So, sound travels as a series of these compressions and rarefactions, and this is why sound needs a medium, something like air, water, or a solid, to travel through. It cannot travel in a vacuum, because in a vacuum there are no particles to vibrate.
This is a very important point, students. Please remember this. Sound waves are longitudinal waves. What does that mean? It means the particles of the medium, they vibrate back and forth, parallel to the direction in which the sound is moving. They don't travel all the way, they just pass the vibration along.
Okay, now that we know what a sound wave is, let's see how we can describe it. We will now look at its key characteristics and properties. First, we have wavelength. Its symbol is the Greek letter lambda. Wavelength is simply the distance between two consecutive compressions or two consecutive rarefactions. And since it is a distance, its SI unit is the meter.
Next up is frequency, represented by the symbol nu. Frequency is the number of complete oscillations or waves that pass a point in 1 second. Its SI unit is hertz, which we write as Hz.
Then we have amplitude. You can think of amplitude as the strength of the wave. It's the maximum disturbance of the particles of the medium from their mean position. A larger amplitude means more energy, and as we'll see, a louder sound.
Now, this is a very, very important formula that you must memorize for your numerical problems. It connects speed, wavelength, and frequency. The speed of a sound wave, v, is equal to its wavelength, lambda, multiplied by its frequency, nu. So v equals lambda into nu.
Students often get confused between these two terms, pitch and loudness. So let's be very clear. Pitch is determined by frequency. A high frequency means a high pitch, like a whistle. A low frequency means a low pitch, like the sound of a drum. On the other hand, loudness is determined by amplitude. A high amplitude means a loud sound. Simple.
Okay, let's move on to our next topic. We are now going to discuss what happens when sound waves hit a surface. This is called the reflection of sound.
You must have heard an echo, right? An echo is simply the repetition of a sound that is caused by the reflection of sound waves from a surface back to the listener.
Now, why do we hear an echo in a small room? Well, it's because the sensation of any sound persists in our brain for about 0.1 seconds. So for us to hear a distinct echo, the reflected sound must reach our ears at least 0.1 seconds after the original sound. And this time gap leads to a condition for distance. Based on the speed of sound in air, which is around 344 meters per second, we can calculate the minimum distance required to hear an echo. And that distance is 17.2 meters. The obstacle must be at least 17.2 meters away.
Reverberation is a little different from an echo. It is the persistence of sound in a large hall due to repeated reflections. This can be undesirable, like in an auditorium, because it makes the sound unclear. That is why sound-absorbent materials, like carpets and curtains, are used to reduce it.
Let's now explore the spectrum of sound. Can we hear all sounds? The answer is no. So, let's look at the frequencies we can and cannot hear.
This table shows the different ranges very clearly. Sound with frequencies below 20 Hz is called infrasound. We cannot hear it, but animals like rhinoceroses and elephants can.
The sounds we can hear, the audible range, is from 20 Hz to 20,000 Hz. And sounds with frequencies above 20,000 Hz are called ultrasound. Bats and dolphins use ultrasound.
Now, this high-frequency sound, ultrasound, is extremely useful. It has many important applications in both industry and medicine.
Let's look at some of these uses. Ultrasound can be used for cleaning parts that are hard to reach. It is also used to detect cracks in metal blocks. In medicine, it is used for imaging our internal organs, like an echocardiography or the ultrasound scans you might have heard of. It's even used to break kidney stones into small grains without surgery.
Here's a good example of how it's used in industry. You see, ultrasound waves are passed through a metal block. If there are no cracks, the waves go straight through. But if there is a flaw, like a crack, the waves get reflected back. This helps us detect defects that we cannot see from the outside. All right, we've covered the concepts. Now for the most important part, how to score well in your exams. Let's talk about a strategy for your physics paper, specifically for this chapter.
When you get a numerical problem, don't panic. Just follow these 4 simple steps. 1. Read the question and list all the given values with their proper units. 2. Identify which formula you need to use. 3. Substitute the values carefully into the formula. And 4. Calculate the final answer. And, very importantly, write the correct unit. This will help you solve any numerical correctly.
So, we have revised all the key concepts of this chapter. You understand how sound is produced, how it travels, and its many applications. You also have a clear strategy for your exam. So, you are very well prepared. Just stay calm, trust what you have learned, and you will do wonderfully. All the very best.